And B, okay, B, two sets. So okay, that A and B, two sets. Okay. Okay, so a relation from A to B, or we should say from set A to set B, okay, is a subset of A times B. So basically, what does this mean, guys? What does this mean? Okay, that say you have maybe A times B is 1, 2, 3, 4, 5, 6. Okay, so say this is A times B. Okay, so A is equal to 1, 2, 3. Okay, and B is equal to 4, 5, 6. Okay, so what this means is that A is a subset of A times B and B is a subset of A times B. Okay, so basically, guys, what it means is that because every element of A, every element of A is in A times B, and every element of B is an element of A times B. That is why A is a subset, okay, of A times B, and B is a subset of A times B. So this is what this really is trying to say, okay? So just try and understand that. Okay? Just try and understand this. So now we're going to move on to another part. So we are almost done, I think, with this chapter also. I think we are almost done with this chapter. Now I know I'm going tremendously fast, but this is because I'm clearing the theory very fast. I'm not trying to waste too much time on theory, because theory should be very straightforward And then when you do the practice questions, the exercise questions, then all the basic theory that I've been teaching you, then it will come out. And when I explain everything, you'll understand it better and you'll be like, okay, now I understand it. Instead of wasting time explaining each and everything again and again and again. So now we're going to talk about total number of relations. Total number of relations. Now this is going to be a little complicated, but we'll figure it out. Okay, so this is basically the same thing. Okay, let's assume, guys. Let's assume. Okay, let's assume A and B are two non-empty sets. Two non-empty sets containing elements M and N. Okay, and then A times B is equal to M times N, as you already know. You know, ordered pairs. Ordered pairs. Okay, ordered pairs. So the total number of ordered pairs okay, I'm very sorry guys. Total number of ordered pairs, yes, there. Total number of ordered pairs of subsets, sorry guys, but of subsets of A times B is equal to 2 to the power M times 2 to the power of M. Okay, A times B is equal to 2 to the power of M times N. Okay, so that's what it is. So basically, say M has 3 elements, N has 2 elements, then it will be 2 to the power 3 times 2, which is 2 to the power of 6, which is 64. Then the total number of relations, then the total number of relations that you will have, the total number of relations that you will have is going to be 64. Okay, that's how it is. So now I'm going to explain something else to you pretty fast, but I hope you can see this. Okay, I hope you can see this. So we're almost done with this chapter. We are almost done with this chapter. So let me just give you some more insight to this chapter, and then we are done with relations also. We are done with the theory of relations, not with the exercise questions. I'm going to cover the exercise questions as fast as I can as well. So let's just do it. Okay, so let's just talk about in how many ways you can you can represent a relation. So guys, a relation can be represented in roster form, okay, set builder form, set builder form, okay, arrow diagram, and lattice. So basically you already know what roster form is and what set builder form is. we've discussed this in sets, but you don't know what an arrow diagram is and what a lattice is. Don't worry, you'll get to know what these are when I do the practice questions. Okay, so guys, an arrow diagram is basically when you draw arrows, when you're grouping Cartesian products, and a lattice is something which I'll have to demonstrate. I can't explain it like this because there is no explanation for it, there's only a demonstration. When I do it, I'll tell you. So now there are two things left, guys. Okay, that's domain and range of a relation and inverse of a relation. So the domain and range of a relation. Domain and range of, okay, of a relation. Okay? So the set of all x values